7.4e is in echo, trigonometry, vectors, operations, and the dot product. We're ready to start on example 7 on finding the angle between two vectors. So I've got one vector that is 3, 4, and I have another one, 2, 1. Alright, let's take the final equation that I gave you, and we used, instead of u dot v, we used ac plus bd. The book doesn't teach that. I'm not sure why. u v. Alright, now we're just going to fill in the blanks. So the cosine of theta is going to be a c plus b d over u and v. So uv, let's just write that as u 3, 4, and then v is going to be 2, 1. And if you look at page 306, gosh, where was it? It was on the bottom of the page. We found that the absolute value of u and the absolute value of v is, if you remember, a squared plus b squared. So on the bottom here, we're going to, well, let's write this top here back. We're going to write square root of 3 squared plus 4 squared. Okay, that's for this one. And then we're going to write the square root of 2 squared plus 1 squared. And that's for that one. And that equals the cosine of theta. Remember what we're doing there. So we've got, let's see if I can write all this. Let's do it in blue. So 6 plus 4, that takes that away, over 9 plus 16 is 25, square root of 25 is 5, times square root of 4 plus 1 is 5, so times the square root of 5. So that's going to be 10 over 5 square root of 5, which is going to be 2 over the square root of 5. We don't have to rationalize the denominator. Just divide that out, and you'll find that you get 0.89443-ish. Okay, now the reason we did not rationalize that out is because that is not our answer. If it's not our answer, we don't have to rationalize the denominator yet, because what our answer is going to be an angle here. So that is the cosine of theta. So now if we take, I don't have enough room here. Let's see if we can move some junk out of here. Let's move this out and this out. Okay, so I've got some room down here. Cosine -1 of 0.89443. So we're taking the arc cosine to find the angle. You're going to find that that's 26.57-ish degrees. And that is using the geometric interpretation of the dot product in order to find the angle between those two vectors, u and v. So I think it's the last thing. Yeah, it is the last thing. Bottom of page 311 gives you a little table there that if your dot product is positive, like the angle we just had, we know that our angle between two vectors is acute. If our dot product is 0, then our angle is a right angle. And if our dot product is negative, we have an obtuse angle. So, if we have our coordinate plane there, and we have B, and we have A, and A dot B is 0. We find out that that's 0, then that is a right angle. That's a 90-degree angle there. So that makes it a little bit easier because, you know, the formula is the cosine of theta equals U dot V over absolute value. If I know this is a positive number, I know my angle. I don't know what it's going to be, but I know at least it's positive. Or it's an acute, it's less than 90. And I know that if that number that I get here is a negative answer, my angle is going to be obtuse. But I also know that if this dot product is 0, so if my AC plus BD, if I get 0 there, which is what that is going to be, I know my angle is a right angle right here. And I don't have to go any further. I just go, oh, my angle right here is a 90-degree angle. I don't even have to continue on. So look at that first. If you get 0, when you plug your numbers in there, you know it's a 90-degree angle and you can stop. That is it for lesson 7.4. Let's just real quickly look at the homework. Pretty much 1 to 18 are pretty simple. When you get into 25 on, you're doing the same kind of things that we just did as a lecture. So I'm not really seeing that you're going to have a whole lot of trouble with these. Use your book, use your lecture notes to make sure that you're doing everything correctly. I'm just trying to see here if there's anything weird going on. 49 to 52. It's giving you like your forces of 250 and 450 newtons forming an angle of 85. The 250 and 450 newtons is the magnitude. It's just the strength of that line, or I shouldn't say it, but it's really the length of that line. So they're giving you two lengths there, and they're giving you the angle between those two lines of 85 degrees. So you're given two sides of a triangle, and you're given the angle between them as 85 degrees. So you should be able to find the length of that angle, or the length of the resultant, the average between those two. So shouldn't give you any trouble, I don't think.